In this chapter, we will be using calculus as a tool in curve sketching. In this video, we'll be sketching the curve of x squared minus 2x plus 4 divided by x minus 2.
All right, everybody, one more graph for this video here. So x squared minus 2x plus 4 over x minus 2, actually just a nice rational expression here. It does have kind of an interesting little feature to it, but there's really nothing too terribly extraordinary about this. First of all, number one, let's take a look at the domain. And I think that's pretty clear. X cannot equal 2. Now, normally I would take a look at my numerator and see if I could factor that down and cancel that out. But actually, the numerator won't factor in a way that allows me to cancel. Like, I might look at this and think, well, is that a removable discontinuity or an essential one? But let's just take a quick look at the discriminant of the numerator. That's going to be negative 2 squared minus 4 times a times c. So that's going to be 4 minus 16. Notice that that's going to be less than 0. The whole point being, if the discriminant of a quadratic is a perfect square, then you should have been able to factor it. You should have been able to see something in there that could have simplified it. That's not going to factor nicely at all. In fact, it won't factor without complex numbers there. So that's good. That's good. 2, intercepts. Okay, well, first of all, let's take a look at the y-intercept here. So f at 0 will be 0 squared minus 2 times 0 plus 4 over 0 minus 2. And it doesn't take much to figure out that that's going to be negative 2. So our y-intercept there is going to be negative 2. The x-intercept will be where f of x is equal to 0. And that will be x squared minus 2x plus 4 over x minus 2. The denominator is not going to be responsible for that, so I could multiply through by the denominator. That's going to be irrelevant. X squared minus 2x plus 4. And actually, ironically enough, I just did the work on this. Notice that the discriminant, and I did that work up here to see if I could factor it, the discriminant was equal to negative 12, which means no solution. So there's no x-intercept. The y-intercept is negative 2, and there is no x-intercept. Okay, whoops. I don't know if you just saw that, but the lead of my pencil just went flying. Okay. 3. We're going to look at symmetry. Okay. Now I have a suspicion, I have a suspicion about this immediately. Just because of the combination of odd and even terms here. So if I plug in negative x squared minus 2 times negative x plus 4, whoops, I don't know why I did that, all over negative x minus 2. Oh, sorry, you didn't see that. The negative here disappears because of the square. This becomes positive 2x. 4 doesn't change, and then I can factor a negative out of the denominator. So that the whole thing, I can take that negative out there, out of the whole thing, and make that x squared plus 2x plus 4 over x plus 2. But that's not the original. So it's not odd. And the negative didn't disappear, so it's not even. So this is neither odd nor even. Okay. Let's take a look at asymptotes. Well, I know that it's got a vertical asymptote. I know that it has an essential discontinuity that x is equal to 2. So the trick is just to figure out what's going on there. So if we take the limit as x approaches 2 from the left of our function, let's just go up here. If I approach 2 from the left, just think about my number line. So here's 0, here's 2. If I approach 2 from the left here, I'm going to get a number that's close to 2 squared. It's going to be close to 4. This is going to be a number that's basically close to 2. So negative 2 times that's going to be close to 4. So these are going to kind of cancel. I'm left with a positive. And if I take a number that's close to 2 but from the left and subtract 2, subtract, it's going to be, this is going to be negative. So positive over a negative, this whole thing down here, this is actually going to go to negative infinity. If you take the limit as x approaches 2 from the right, and okay, listen, I know what I'm doing is a little quick and confusing. If you watch it kind of again, hopefully you'll see what I'm doing here. I'm now going to let x approach 2 from the positive side. So I'm looking at what each piece here does. If I approach 2 from the positive side, x squared is going to get closer and closer to 4. Negative 2x is going to get closer and closer to 4, and again, those will basically cancel, and I'm going to be left with a positive 4 there in the numerator. This x is approaching 2 from the positive sign, which means it's slightly bigger than 2. When you subtract 2 from that, you're going to get a number that's slightly bigger than 0, so it's going to be positive, but it's really close to 0. Positive divided by a positive, it's going to get you a positive. So it's going to go up to positive infinity. So basically, if here's 2, it's going to go down on this side, up on that side. Awesome. Now, because the degree of the numerator is greater than the degree of the denominator, it doesn't have a horizontal asymptote, but it might have an oblique one. So we got to check into that. So what I'm going to do here is I'm going to do the division. X minus 2 divided by x squared minus 2x plus 4. Okay, well I can get rid of the leading term there by multiplying my divisor by x. So x squared minus 2x, well that's beautiful. And when you subtract that, it all goes to, basically, what if I subtract down here, I'm just going to get a 4 there. Which means the degree of my remainder is less than the degree of my divisor, so I'm done. So essentially, x squared minus 2x plus 4, okay, divided by x minus 2 is going to be the same as just x plus 4 over x minus 2. Essentially what we're saying with that remainder is there's this little piece left over that still needs to get divided by x minus 2. I'm just not sure what to do with that. Now, as I let x go off to infinity, positive or negative infinity, notice that this piece right here, because the x is in the denominator, this piece is going to go to 0. So I'm just going to be left with x. And so there's my horizontal asymptote, or sorry, my oblique asymptote. Y equals x. Now, I can do one other little thing about this, okay? Just when I take a quick look at this. If I want to know how this thing is going to behave, when I take the limit as x goes off to infinity of this thing right here, it's going to equal the line y equals x plus, if I go to positive infinity, I'm going to get a positive number divided by, now bear in mind, I'm going to infinity, so this is going to be a positive number. So this is going to be just slightly larger than x. So here's my line, y equals x. As I go this way, it's going to be equal to x, the line, plus a little bit. If I go this way, it's going to be equal to the line, but now this will be a positive number divided by a negative number, because remember, if I go to the left, I'm letting x go to negative infinity. This denominator will be negative, so it's going to be the line plus a small negative number, so it's going to be here. So essentially the graph is going to come below the line to the left and above the line to the right. Just because of this piece right here either being positive or negative when I let x get really, really big in either direction. So I have a little bit more of an idea of how this is behaving just by looking at that right there. And like in a previous question here, that's actually enough for me to have a pretty good idea what this graph looks like. I could probably draw it from at this point right now. But let's take a look at the derivative. So 5. So when I take the derivative, and I'm going to take the derivative using again, the quotient rule here. That's going to be the derivative of the numerator multiplied by the denominator minus the numerator multiplied by the derivative of the denominator, which in this case is just going to be 1, all over the denominator squared. Now, in this case right here, there's really nothing that I can factor out. The best that I can really hope to accomplish here is just to simplify the numerator a little bit. So I'm going to multiply this out here. That'll be 2x squared. What do I get here? Minus 4x minus 2, so minus 6x plus 4 minus x squared plus 2x minus 4. So that is going to get me x squared, what do I got here? Minus 4x, and that's it, over x minus 2 squared. Okay. And actually I can factor that numerator, make that x times x minus 4 over, x minus 2 squared. Okay, so now I got my pieces here. I'm going to use my little chart over here to investigate how this is behaving. I know there's going to be an issue at 0, 2, and 4. 0, 2, and 4. Okay, those are all of the pieces where my pieces here have issues here. So let's start with x. And again, all I'm interested in is signs. So it's going to be 0 here, positive, 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 and negative there. X minus 4 is going to be 0 here, positive here, negative, 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 negative in the intervals and at those numbers. X minus 2 squared is going to go to 0 at 2, but because of the square, it's going to be positive everywhere else. So now I can put this all together to get my function, which will be a negative times a negative divided by a positive, positive. A 0 times a negative divided by a positive is going to be 0. Positive times a negative divided by a positive will be negative. Here I'm dividing by 0, so undefined. This is going to be negative again, 0, and positive. So my function, and now I'm running out of room here, so I'm going to have to kind of speed this up here. My function is positive on this interval and this interval, okay? So that means my function is increasing on the interval from negative infinity to 0, and then including the 0, union, and what's that going to be, 4, out to infinity. This thing is decreasing on the interval 0 to 2, but not including the 2, because the 2 is going to be the vertical asymptote. Union, then it's going to be from, it looks like 2 again, out to 4. Okay. Okay. And actually, because of this right here, we can put this together. I'm going to just slip 6 into here, the last little bit here, because take a look at this. What I've got here, I've got an increasing sequence ending at, increasing interval ending at 0, and a decreasing interval starting at 0. Increasing, decreasing. Well, that means 0 is my max. And we already saw that that's going to give, that is my y-intercept at -2. So I'm going to have a max at 0, -2. I have also got an increasing interval. I keep saying sequence, it's not what I mean. An increasing interval that starts at 4 and a decreasing one that ends at 4. So decreasing to 4, starting at 4, which means I'm going to have a minimum at 4, comma. Okay, now I got to do a little bit of work here because I got to figure this out here. That's going to be 4 squared will be, I'll just do it over here, 16 minus 8 plus 4 over 2. So looks like, what is that, 6? 16 minus 8 is 8, plus 4 is 12, divided by 2 is 6, yeah. So way down here, we're going to have this minimum at 4, 6. Whew, good. Almost there. Now we've got to take a look at concavity. Okay, let's remember our function here. Let's take the derivative of this one right here. X squared minus 4x over x minus 2 squared. So the derivative was x squared minus 4x over x minus 2 squared. Is that right? Whoops. Is that right? X squared minus 4x over x minus 2 squared? Yeah. Okay, good. Now let's take the second derivative so we can investigate concavity. Almost done here. Almost done. That is going to be 2x minus 4. That's the derivative of the numerator, multiplied by x minus 2 squared, minus the numerator, multiplied by the derivative of the denominator, that's kind of big and bulky, over x minus 2 squared squared to the fourth. All right, what can we take out here? Well, Oh, actually, you know what? I'm gonna factor just a little bit more here, just so that we see everything. So I have got a 2, x minus 2, x minus 2 squared, minus x, x minus 4, to x minus 2 over x minus 2 to the fourth. I just wanted to make sure that everything was factored, so when I pull stuff out, it's clear what I'm doing. Okay, I've got an x minus 2 here, an x minus 2 here, and two factors of 2. So that's what we're going to take out. 2 x minus 2. That is going to leave me with x minus 2 squared minus x minus 4. Okay, well that wasn't... Sorry about that. That wasn't quite as useful as I was expecting it to sort of be there. Okay, well one of the x minus 2 terms factors cancels. So this will be 2 multiplied by, this will be x minus 2 in the denominator cubed. This will be x squared minus 4x plus 4 when I expand that x minus 2 squared, minus x squared plus 4x. Oh, I like what I just saw there. This is looking good, because that will cancel with that. That will cancel with that. I'm left with just 4 times 2. That is beautiful. That just became 8 over x minus 2 cubed. Well, that was outstanding. So, my second derivative here, okay, doesn't ever go to 0, but it is undefined at 2. If you pick any value of x less than 2, that binomial becomes negative, and the cube is going to keep it negative. So it's going to be negative here, and then on the other side it'll be simply positive. So my second derivative is less than 0 on the interval negative infinity to 2, which means this thing is concave down from negative infinity to 2. Second derivative is going to be positive on the interval 2 to positive infinity, which means it's concave up from 2 to infinity. And this, and I'll plug in point 8 here, this should clearly illustrate that we've got a point of inflection here. Concavity is changing at the point 2, comma, yeah, I don't know what it is. Oh, I'm sorry. I'm sorry. Oh my gosh. Yeah, okay, this is lack of caffeine talking. Okay, I'm going to just come back up here, and I'm just going to delete all of that. Yeah, clearly I need to have a little bit more caffeine today. Keep awake here. Hoy, everybody, I do know that it's undefined at 2. I do know that the function's undefined at 2. So there is no point of inflection. What that was that's an asymptote, and that's why the behavior is changing on either side there. I'm so sorry about that. This has been a long one. Let's just jump right to the sketch here now. Okay, I know that this thing had a y-intercept here at like -2. I know that it had an asymptote here at +2. In fact, that was the issue. I should have known that to begin with. I know that it had a maximum value here. And I know that it had a minimum, and I think it was at 4.6. So it had a minimum right there. Now, it's interesting that the maximum is less than the minimum. But that's because this thing, whoops, sorry, my graph isn't going to do me justice here. But I also had this horizontal asymptote here, y is equal to x. I know that it approached 2 this way, and the x is equal to 2 this way and this way. And so I can also look at my derivatives, and my second derivative here. I know that it was increasing here. It was increasing here, decreasing here, and then it was decreasing and increasing. I know that it was concave down, and the only change in concavity was at 2, so it's concave down here, concave up here. So here's what's going on. It was increasing concave down up to the y-axis, and it was approaching this asymptote, so it was doing something like this. Then it's decreasing concave down and approaching the asymptote here. It was decreasing concave up, coming away from the asymptote, approaching our minimum, and then it's increasing concave up and approaching the asymptote there. And so that is roughly what this graph is going to look like.